simplifying, multiplying, and dividing radicals. Okay, so in the first section, we just talked about how to simplify radicals, things like square root of 4, square root of 9, things like that. That simplified out to a nice number. In this section, we're going to be doing simplifying numbers that don't come out to be super nice. Now, the easiest way to do this is to actually list. Wow, let's undo that. Is to list the factors of the number. This should not be a big deal. The numbers are not going to be super large. And then we're going to look for the biggest number that we can take the square root or the cube root or something like that. I think this is going to be easier than some of the other ways I've done it in the past, but let's just try this and see. So we all know how to take the square root of 16, which is 4. But what if I said, okay, let's take the square root of 32? Well, I can't take the square root of 32. So what we're going to do is we're going to list all the factors of 32, and we're going to find the biggest number that I can take the square root of. So let's do 132, 2 and 16, 4 and 8. That's it. Now, out of all those numbers, which is the biggest one we can take the square root of? Well, notice I can take the square root of 16. There's a rule when we're working with radicals that says we can take, let me just do it down here. We can take something under the square root symbol and break it apart and take the square root of each piece separately. That's a rule. So if I had, I don't know, if I had like 7 times 11, I could break that up like this. So as long as we're multiplying, I can do this. Now, it doesn't work for adding and subtracting. It only works for multiplying and dividing. But saying that, I can take the square root of 32 and do it like this. Break it into 16 and 2, just like I did these previous problems over here. So we're taking this rule and applying it right here. Which means we can take the square root of 16 separate from the square root of 2. And look what happens. Square root of 16, we know, is 4. I can't take the square root of 2, so we have to leave it under the square root. Whoa! Leave it under the square root symbol. I don't know what just happened. Let's go back to my... We go back, so we can take the square root of the 4, the square root of the 16, which is the 4, but we leave the 2 under the radical sign, and so our answer is not very nice. It's got a nice number, but then it's got a square root behind it. So the goal is to list the factors and find the biggest one that you can actually take the square root of. Now here's one that's got a lot of factors. Let's just see what we get. So let's list all the factors. 1 and 300, 2 and 150, 3 and 100, 5 goes in there 60 times, 6 goes in there 50 times. Have I found one yet? If you notice, if I put the smallest numbers on the left, then that means our biggest numbers is on the right. So I'm looking at the bigger number to see which one I can take the square root of. I can't take the square root of 300. I can't take the square root of 150. But I can take the square root of 100. If I keep listing these, what's it going to be? 8 go in there, 9, I know 10 goes in there 30 times. 12 go in there, 13, 14, 15 goes in there. How many times? 25, I think. No, not 25. 20, see 15. I don't think that goes in there evenly. But, you just keep going. You can find, the biggest one's going to be on the right side if you do it like I'm doing it. 15 doesn't goes in there. Let's see, 26. Right. No, I don't think it's about. Yeah. So we can break this apart as 100 times 3. And use that little rule that says we can break it apart into 2 square roots. I can take the square root of 100, which is 10. I can't take the square root of 3, so we just leave it alone. And that'd be my final answer. Let's say we got the square root of 72. 72 is not a nice number we can take the square root of, so let's just go list it. The factors, 1 and 72. I can't take square root of either one of those. 2 and 36. 3 and 24. Just 4 go in there. 4 and 18. 6 and 12. 8 and 9. Now, I'm looking for the biggest number that I can take the square root of. Biggest number is 36. We rewrite this 72 as 36 times 2. Break it apart. We'll get 6 square root of 2. I think it'll be a lot easier if you do this. Or list out the factors. Same thing for cubed roots. Let's say I had the cubed root of 54. I'm going to list out all the factors of 54. 1 and 54. 2 and, was that 27? 3 doesn't go in there. 4 doesn't go in there. 5 doesn't go in there. 6, I think that's it. Let's see, no, 6 and 9 goes in there. Now, which of those numbers can I take the cubed root of? Which of those numbers is a number times itself 3 times? Well, that's 27. 3 times 3 times 3 is 27. So we can break this apart as a cubed root of 27 times 2. Break it apart one more time like this. The cube root of 27 is 3. Then we've got the cube root of 2. Here's my final answer. So I really think it'll help you if you list them out. I mean, you don't have to. You can do whatever you want to. But it may help if you list them out to find the biggest one. So you want the biggest. You just don't want one of them that goes in there. You want the biggest one that I can divide in there. Now, let's talk about variables. There's the rule, I told y'all earlier in the other lesson, if you got the square root of x squared, that just gives you an x. If you got the square root of x to the 10th, that would give you x to the 5th, so you're breaking it in half. If I had the cube root of x cubed, that's just x. If I had the cubed root of x to the 12th, well, you divide the exponent by whatever. Remember, this is called the index. So you divide the exponent underneath by the index, and that'll give you the answer without the root sign. Okay. Suppose, though, I gave you this. Oops. X to the 11th. Well, what's going to happen? I can't divide. Now remember, our index of a square root is 2. I can't divide the 11 evenly by 2. So how in the world am I supposed to do this if it doesn't work? Well, when you're working with these variables, your answer will have a variable on the outside and some exponent. You'll have a variable left on the inside. You'll have the same variable left on the inside. And it's got an exponent. So in other words, if it doesn't go evenly, you've always got a remainder. When you're working with roots, if the exponents can't divide evenly, you're going to have something remaining under the radical sign. You're going to have a remainder. Now, I'm going to show you this way, and I'll show you another way. So what you do is you just divide. In this case, 2 goes into 11 5 times. Now, this 5, it's on the outside of the division symbol. So the 5 goes on the outside of the radical. So I've got 5 x's out front. And when I do my subtraction, I'll get this. Now I've got 1 left underneath the division symbol. So I'm going to have 1x left underneath the radical sign. The top is how many is on the outside. The remainder is how many is left on the inside. Let's do some more though. It takes a little practice on this. Let's say I had square root of x to the 33rd power. I'm going to have x's on the outside. And I'm going to have, I'll even tell you this much. If this is a square root and it doesn't go evenly, you're going to have 1 left underneath the radical sign. Your exponent underneath will be a 1. But let's go divide 33 by 2 and see what happens. 2 goes into 33, was that 16 times? So on the outside exponent, we're going to have a 16. Then we finish it out, and I've got 1 left underneath the radical sign, x to the first power. Let's say I had the square root of, let's do 2 variables. 4 y to the 9th. Whoops. Well, y to the 9th. Now if I've got 2 variables, I can do this. I can break it apart and do each variable separately. That might be the easiest way to do it. Alright. This one is easy to do. The square root of x to the 4th is x squared. But this one, I can't divide evenly, so we're going to have some number of y's on the outside and some number of y's on the inside. We just got to figure out what the exponents are. Well, let's come over here and take the 9, divide it by 2. So 2 goes into 9 4 times. So the exponent on the outside will be 4. Finish it out. The exponent underneath will be a 1. So the final answer for this one is x squared, y to the 4th. Behind it is a square root of y left over. We're going to do another one like this, and then we'll do some cube roots. Let's say we had square root of x to the 5th, y to the 6th, z to the 11th. Now, notice I've got x, y's, and z's. On the outside, we're going to have x's, y's, and z's. And underneath, I'm going to have something left because they don't divide evenly. Let's start with the 5s. If I divide 2 into 5, it goes 2 whole times. So the x on the outside will have a 2. Finish this out. The remainder is 1, so it'll have 1x left underneath. Look at the y. If I divide 2, it goes evenly. So we're going to have 3 on the outside and no y's left over. Then we come to the z. If I divide 11 by 2, it goes 5 times. So that means there's 5 z's on the outside. Subtract. I got a remainder of 1, so we're going to have 1z left underneath the radical sign. Now, there's another way you could do this. It's not my favorite way, but I'll go ahead and show you. You could, say I had this, x to the 13th. You could do this by listing out x's 13 times. Since this is a square root, you can circle pairs of x's. Now, how many pairs of x's did I circle? Well, that is 6. So you would have 6 on the outside as your exponent. There's one x I didn't circle, so it's got to stay underneath. Now, this may look easier for some of you, which is fine. The reason I don't like this is because what if that exponent was a 63? Are you going to list out 63 x's? Well, of course not. But if the exponent is kind of small, you can do this. So the number of pairs that you circled is the exponent on the outside, if you want to do it this way. So that's the number of pairs. Either way works for me, whichever's easier. I don't really care. But let's do some cubed roots. Let's say I had the cubed root of x to the 11th. Well, I can't divide 11 by 3 evenly, so I'm going to have some x's on the outside, and I'm going to have some x's on the inside. And this is a cubed root. Don't forget to put the little index there. Well, let's come over here to the side, and let's divide. So we'll have 3 goes into 11 3 times. So the number of exponents on the outside will be 3. Finish this out. The number of x's on the inside will be the remainder, which will be 2. Let's say I had the cubed root of x to the 22nd power. Well, I'm going to have x's on the outside and some x's on the inside. Okay, let's divide. So 22 divided by 3 goes 7 times. So 7's on the outside. Finish it out. 1 remainder. So we've got 1 remaining underneath. So this one is x to the 7th times the cubed root of x. If you had multiple variables, you're going to do it the same way. So multiply them together. So let's do one. I want to show you something on this. Let's say I had the cubed root of x to the 7th, y to the 5th. Now, we can split this apart like we did earlier. Remember, the only time you can do this is if you're multiplying or dividing. I haven't done any dividing yet. Now, let's look at the x's. 7, divide 7 by 3, it goes 2 times. We're going to have 2 x's on the outside Finish it out. And we're going to have 1x on the inside. Take the y's. 5 divided by 3 goes 1 time. So we're going to have 1y on the outside. Finish it out. And we'll have 2 y's left underneath. Now, you can't leave your answer like this, split apart. So, whatever's in front of the root symbols, put those next to each other. Whatever's under the root symbol, put those together under the root symbol. So you don't want to leave it separated, you want to squeeze it back together to look like that. So you'll have something on the outside, you'll have something on the inside. Alright, let's do one more like that, just to make sure we understand. Let's say I have the cubed root of x to the 17th, y to the, I don't know, first power. Let's do a different, let's do 2. Let's change that to a 2. So I'm going to split it apart. Cube root of x to the 17th, and then do a cube root of x squared. So let's start with the x's. 3 goes into 17 5 times. So we'll have 5 x's on the outside. Finish it out. We'll have x squared left underneath. Now, can I divide 3 into 2 any whole number of times? Well, it doesn't go in there a whole number of times, so I can't do anything with the y. So it's just got a y squared left underneath. But I can't leave it like that. We have to rewrite it. Put the x squared and the y squared together under a root symbol. Got to rewrite it like this. Now, you're going to have problems where you have to do let's do 50 x to the, you'll have to do a number and a variable in the same problem. But again, this is a square root. We're just going to split it apart. And we're going to work with each one of these separately. I'm going to put parentheses here. Alright, let's think about 50. I can rewrite 50 as 25 times 2. I'm going to leave this alone just for right now. Square root of 25 is 5. Square root of 2. For the x's, we're going to have some on the outside and some on the inside. So come over here. Divide 9 by 2. Goes 4 whole times. So we'll have 4 on the outside. Finish it out. We'll have 1 left underneath. I can't leave my answer like this. So put the 5 and the x to the 4th next to each other. Put the 2 and the x next to each other underneath the radical sign. Alright. Sometimes we have to reverse that I just did. Say I had this. If you're multiplying 2 roots together, as long as they're the same index, you can actually multiply the numbers underneath. And you're going to go through the process of simplifying it. So it would look like this. So sometimes your problem is going to say simplify, but you're not going to be able to do it as it's written. You'll have to multiply them together and then simplify it. Let's say I had the square root of 3 times the square root of, 8. Well, first thing we're going to do is multiply them together. figure out a factor of 24 that I can take the square root. Biggest one is 4. Then we take the square root of the 4 and leave the 6 alone. So if you're asked to simplify and you've got a root times another root, as long as they're the same roots, you can multiply them together and simplify. But, I mean, make sure we understand this. Have to have the same index. That's important. Now let's talk about division. I did one like this earlier in the other lecture. Let's say I had square root of 4 over 9. The rule says we can break this apart and take the square root separately. So it's just like the multiplication. I can split it apart, do what's in the top, do what's in the bottom separate. Let's say I had 8 over 25. Break it apart. Then we're going to simplify it. Now, 8 is one of those problems I can't do nicely. So let's come over here. We can break 8 apart as 4 times 2. We can take the square root of 4, but I can't take the square root of 2, so my numerator will be this. I can take the square root of 25, which will be 5. So the final answer is this. So you're just doing 2 different square roots in the same problem. Let's do another one. Let's say we had, I don't know, whoops. Let's do square root of 27 x to the 3rd over 81 y to the 4th. So we can break it apart. 27x cubed up top, 81 at y to the 4th on the bottom. Well, here's the good news. I can simplify the bottom. That's just 9y squared. For the 27, let's come over here. Let's break it apart. We'll do this. We can rewrite 27 as 9 times 3. Square root of 9 is 3. Square root of 3. Now this one, it doesn't go, I can divide the exponent by the index. It doesn't go evenly, but we've already done this one earlier. We'll have 1x on the outside and 1x left underneath. Now, you can't leave it like this. We've got to simplify it. We got to do a little bit. There's a 3 and an x on the outside. There's a 3 and an x underneath. And luckily I can simplify this one a little bit more. I can divide each one of those by 3. So we'll get x square root of 3x over 3y squared. But the whole thing is, if you can simplify, if you know how to simplify something like we were doing earlier, you're just doing 2 problems in one. So you're just going through the same processes. It's just a fraction now. So we need to make sure we understand that first part really, really, really well. Now, you're going to see problems like this. We might have square root of, 32x cubed over square root of 2x. Okay, if you've got a fraction and it's split apart as a square root in the top and the square root at the bottom, what you want to do is you want to put the numerator and the denominator under a single root. You want to write it like this. Once you rewrite it, you're going to divide and you're going to simplify like all the other problems. This one's pretty straightforward. 4x. Say I had square root of, I don't know, let's do 50x to the 9th over, and just do 2x to the 5th. So again, take what's in the numerator, take what's in the denominator, and put it under one big radical symbol. Simplify 25x to the 4th. Then we can take the square root of the 25 and the square root of x to the 4th. So you got a bunch of stuff you can do, but if you can do the first part of this, back up. If you understand all this stuff on these first slides, then you can do the multiplication. You can do the division. Okay, I can't even talk today. You can do the division problems. I know. If you understand how to simplify each piece, you can do this. Now, this is kind of a long lecture, but I'm trying to get everything done in chapter 10. This is on the final. But you need to practice simplifying. You need to do it. Definitely you have to do the homework, turn in, but just don't write something down. You need to be working on this stuff. All right, work on the homework. If you got any questions, you can email me, or during my office hours, you can Zoom me, whatever.